Hey guys, welcome to the part 2 of building a conversational chatbot series. In the part 1, we created a bot using Amazon Lex and we tested out on AWS console. If you can see, so when we ask about the weather, it will ask for the city and we can just type in any city and it will respond back our mock information. Now I can ask questions like this as well. What is the weather in Colombo? So in this particular case, it is not asking for the city because it extracts the city name from the question itself. So we still are not communicating with the actual API. So in this part, we are going to hook up a Lambda that actually talk to an open weather map API and get the actual weather information. So let's start creating a Lambda function that will be invoked by Amazon Lex to get weather information. So for good measures, I will be using Serverless framework. So in the previous videos, I've mentioned how to install this serverless framework. So if you visit this link, you will be easily follow these steps and get it installed. Now I will go into my terminal and let's see where am I. I will go into my desktop. I will create a folder, chatbot, and I will cd into that particular folder. Now let's create a serverless service. So in order to create a serverless service, we are going to use this particular command. Serverless create dash dash template AWS Node.js dash dash path. The name of my service, we'll call it mybot. Now it will create a template, AWS Node.js template. So I can start building my serverless function or Lambda function. Okay, if I do a listing, you will see my service name appearing there. So I will go into that my bot folder and I will open it in Visual Studio Code. Alright, now as you can see there are three files. Serverless.yml is the configuration file. So let's clear out this clutter. I will take out all these comments. Right, when you remove the comment, you'll see only a couple of lines of code here. So first, we can give a name to our Lambda function. So the default one is hello. We will change it to get weather because that's what our function's main task. So I will add the same name to our handler function as well. Save it. And if you go to handler.js, you will see it has some boilerplate code. Instead of this hello function, I will rename back to the get weather function and I will take out this code. Or in fact, I will take out all this code. Because the previous code is relevant if we are invoking this Lambda function through an API. But now we are allowing AWS Lex to call this Lambda function. So there's a certain structure of JSON that needed to be written so that AWS Lex will understand the response coming from the Lambda function. Now I want you to go to this particular repository. Let me take a web window. And if you go to this particular repository, github.com/mjson/web-weatherbot, you will see there's this Lambda function folder. If you go into that, you can see those files and go into the handler.js file and let's copy in the code. I will copy it and I will go back to my Visual Studio Code and I will paste it in. Okay, now that I have pasted in the code, you will see that we are requiring a dependency called Axios. So this particular library helps us to send an API request to our Open Weather Map API and get the weather information for a particular city. Now let's go through this code and I want you to focus on this return function. So in this return object, As you can see, there's a certain structure. So it has a session attribute, dialog action, and there are some other attributes as well. Now this is a required structure where the AWS Lex can understand it. So we have to make sure we are returning the information in this particular structure. So what is a dialog action? Now there are different types of actions our AWS Lex can respond to. Note that the type of the dialog action is close. This means Lex does not expect a reply from the user. So once this response is sent to the user, he is not expecting any response back from the user. So it's closing the conversation. And the fulfillment state is fulfilled. And this is where we will send the message. So we will add the type to plain text, and whatever the message that will be shown to the user will be added here. Now, if you can see, we are constructing this variable up here. If I scroll it a little bit up, you will see we are sending an API call using Axios library to a certain URL. And this particular get URL is expecting a city name. Now, let's go to the browser and I will take you to the Open Weather Maps API section. You can sign up to this Open Weather Map and they will provide you some free API keys, or you can create some free API keys with some limitation. Now I have signed in and I've created a couple of API keys. So in order to use these API keys, you can just simply look into their API documentation. Click on API documentation, and there if you scroll it a little bit down, you will see API documentation section. And here current weather data, you can get it by the city name. Just select that. Right, as you can see here, so this is the URL pattern. You have to say api.openweathermap.org/data 2.5 weather. Then we have a query parameter Q and it will accept a city name. Now, in order to actually get the data, we have to append the API key that I shown earlier. So let's get back to our Visual Studio Code. As you can see, this is the same pattern I'm using here. For the city name, I am passing in the city value that we have extracted from the user. So when AWS Lex calling this particular Lambda function, it will send that slot variable value into this Lambda function. We can extract it by its event object, event.currentIntent.slots, and there's this attribute city. Now it is corresponding to the variable that we have defined here, the slot value. So we can simply access that value and then pass that city into the query parameter that is expected from Open Weather Map API. And afterwards you can define the metrics or units. Here I have defined metrics, so I will get the temperature in Celsius, and this is the API ID. Right? So when we execute this, you will return the data, and from the data object you can extract the temperature information by data.main.temp and humidity information as well. And also OpenMap will give you a small description about the weather, so that one also we can extract. Okay. Now there are different other types of dialog actions. Now, as I previously mentioned, this is a closed type, so Lex is not expecting a response from the user, but there could be some other scenarios. There are other types like confirm intent, where the Lex is waiting for the user's response to call upon another intent. For example, let's say a user wants to travel to that particular city once they got to know about the temperature or the weather information. So he wants to know about the flight ticket price. So when that intent is called, get flight ticket price, the logic might need to get that city name again. But rather than asking it from the user again, you can pass that information or the city name in a session attributes. So that's why this particular array or the object is for. All right. So I think now the code is clear to you guys. So let me open up a terminal, and first I will install these dependencies because we have to make sure Axios is installed. npm I Axios. Okay, it's installed. Now let's use serverless to deploy our function. I will say SLS deploy, or you can say serverless deploy, and I will just hit enter. So at this point, make sure that you have configured your AWS credential with serverless. I think I misspelled it, so let me say SLS deploy again. Alright, so our function is now deployed. As you can see, the name is mybot/dev/getweather. Now let me just copy it, and I will go back to the Lex console, and I will refresh. Alright, so earlier we added the mock response. Now we need to call an Lambda function instead. I will select AWS Lambda function, and in the drop down we can search for that particular AWS Lambda function name. So just paste it in and you will see it appears down here. I will select it, and for the version I will select latest. Well, as soon as you select it, it will say we are adding some permission to the Lambda function, because if you can remember, when we are starting up the Lexbot, it has assigned a particular role. So for that particular role, it will add another permission to invoke Lambda. I will say OK. Right? So make sure you select latest, and then let's save it, and we'll build the application or build the bot, and afterwards let's see if it really works. Okay, now the bot is successfully built. So let's close it up, and we'll ask it a question. Tell me about the weather. So it will ask which city. I will say London. Okay, we got an error. So let's do a debug. So let me go into the Lambda function. So you can view the Lambda in the console if you click here. So that will open our Lambda code in the console. And let's try to debug. Well, as you can see, it will load the function code here. So it's still loading. And we have used async and await keywords, which is not supported on 6.10. So let's change it to node 8.110, which this is which async await is available, and this should be our issue. So let's save it and make sure if it works, and let's try it back. I will again ask, so let me try a different utterance. How is the weather in London? So this time it works. So it says the temperature is 14.9 degrees Celsius and the humidity is 77% and few cloud is expected. Awesome. So this is really nice, but I want to do one other adjustment. So for example, when this is embedded into a web application, a user might not directly ask about the weather. He will probably say hi. So at this moment, our bot is unable to recognize this particular utterance. It says, sorry, can you repeat that, please? So in order to make our bot more intelligent, so let's add another intent. We'll call it greet user. Greeting user. I will add it. Right. So what could be the sample utterances? Could be hi. It could be hello. Well, it could be like maybe howdy. Right. So when this is set, we can simply add a return parameters to But I want to make it more interesting. So we'll get the name of the user and give him a customized greeting. So when they say hello or hi, we would say, our bot would say, hi, what is your name? And we will have that name variable into a name variable, and we will set the type as name. Okay, and I will add it. So we have another slot variable called name. So when this is prompted, the name will be filled. So we can customize it. Hello, name. We'll say, how can I help you? That is much more customized. Or else we can say, hi, Manoj, or whatever the name. What do you want? Okay, we'll add these two as well. And I will save the intent and then build it again. And we'll wait until it is built. Okay, now the bot is built successfully. So let's try out one of these conversation starters. So you say hi. So this time instead of sorry, I didn't understand, it says hi, what is your name? So I will say Manoj and press enter. Then it will say hello Manoj, how can I help you? Now I can ask, tell me about the weather today. Then it will trigger the second intent, greeting you, finding weather. Then you will ask the next prompt, sure, which city? I will say Colombo. Yeah, so it has queried the API and sent me the current information in Colombo. The temperature is 30 degree and the humidity is 66 and scattered clouds is expected. I know it's the grammar wise it's wrong, but that's fine. So I believe right now we have a really nice flow of natural discussion. So our bot is ready to be embedded into web application. So we'll do that in the next episode. So thanks for watching.